Kata is coming from the martial arts ideas, where basically you practice something over and over and over again until it becomes embedded in your being, basically, so that you don't have to think in order to do that thing anymore. So the idea with a coding kata is you pick a problem that can be solved by coding, and you just practice it over and over and over again until it just becomes a natural function of what you can do. And we tend to do test-driven development for our coding katas. And the idea is not so much, I mean, to an extent it's solving the problem, but really it's about practicing test-driven development. Because for a lot of people, the biggest problem with trying to do test-driven development is when you just start out, it's very clumsy, and it's not something that most people are familiar with, that style. So what we're going to do tonight is go through a fairly simple one, actually, because I've been sick for the past few days, and so this was what I could prepare in time for tonight. So this is called FizzBuzz. And
which is like the classic
This is
kata,
the
right?
classic kata. It is one of the more basic katas out there. The idea with FizzBuzz is for the numbers 1 to 100, you want to do something to those numbers based on a set of rules. So if the number is divisible by 3, you want to return fizz. And if it's divisible by 5, you want to return buzz. And if it's divisible by 3 and 5, it would be FizzBuzz. And if it has a 3 in the number, you should return fizz. A 5 in the number, buzz. Or if it's any combination of those rules that made up 3 and 5, then it's FizzBuzz. And if it doesn't fall into any of those categories, just return the number itself. So this is what we want. It's sort of an integration level test that basically we've got this set of results that follows those rules. And I've got a quick little test here that basically says that we expect that if we map over the numbers 1 to 100 and use our FizzBuzz to convert the numbers, then it should equal this array of results here. And we're going to start out by making sure that guard is running. It is. And we're going to save this. And we're going to fail. And we see that the problem is we don't have a method called convert on our FizzBuzz class. So we're going to go ahead and make one of those. And since this is a simpler kata, I'm going to pretty much just fix exactly what the problem is and move on. So
you make the text a little bigger.
Yeah, on this one?
Yeah.
Sorry.
Nice, thank you.
Yeah, there we go. All right, so here the problem is I have a convert method now, but I keep sending it this number, and so it needs an argument. So we're going to fix that, and we're going to send it. We're going to take in an argument here, and we're still failing. But now the problem is we've got, we expected this whole thing, and we got an array of nils. At this point, we're going to stop here for a second, and we're just going to comment out our integration test. We could do it pending, but I want it to do all green-red things, so we won't pin. So at this point, we're going to start actually making a convert method and specking it out here. So what we're going to do here is we're going to describe, actually let me pop that up so you can see it. We're going to describe our convert method. And we're just going to give it context. When given 1, the simplest case here, given 1, we'll expect FizzBuzz convert 1 to equal the string 1. And we're going to fail still. And this time the error message is a little easier to read. We expected 1 and we got nil. So we're just going to fix that here. And we're going to say return 1. And we got our first pass.
Nice.
So there we go, we passed. But that's not going to work probably for a whole lot of cases. So we're going to go ahead and duplicate that case, and we're going to give it a 2, because we see that 2 should also give back that number 2 as a string. We fail. We passed 1. We still passed our first test, but our other test failed because we got a 1 when we wanted a 2. So at this point, we can say if n is 1, then we'll return 1. Otherwise, we'll just go ahead and return 2. And that'll let us pass that again. So moving on, we'll add on another one here. And when we are given 7, we would like 7. And that one's going to fail because we got 2 and not 7. So now we're starting to realize that that's going to be very inefficient to be doing a bunch of ifs here. So I'm just going to realize that if we just do a 2s on n, then that should make all our tests pass. And so now we'll start getting a little bit more interesting. So one of our rules says that when we're given something that's a multiple of 3, like say the number 3, whoops. Then we should get fizz. And that fails because we wanted fizz, but we got 3. So that's easy enough to fix. N equals 3, then we'll return fizz. Else we'll do our 2 string. And that passes. All right, excellent. So we'll do another test here. And what we're doing here is we're just continuing to drive out the functionality here. So another multiple of 3 would be 6. So 6. So that should be fizz as well. That failed. We got 6 instead of fizz. So what we're going to do here now is another way of saying that something is a multiple of 3 is if when you divide by 3, you get a remainder that is 0. So we're going to go ahead and change this to say n dot remainder 3, 0. So if the n remainder 3 is 0, then we're going to say fizz. And we pass. But I'm going to go ahead and so I'm going to go ahead and do a quick little refactoring since we're green. When you're doing test-driven development, you never want to refactor unless you're green, unless you really, really have to. But even then, you shouldn't. So I'm going to create a little private method called fizz that takes n. I'm going to say so we're either going to fizz or we're going to 2s our n. And so that passes all our tests so far. So now we're going to move on. So let's move.
80% of people.
So now we're going to go to multiples of 5. So we're going to start with 5. And the rule says with multiples of 5, you should get buzz. And we'll save that and fail because we got 5 instead of buzz. So now let's fix that. So if n is 5, then we'll say buzz, else we'll do this stuff. And we pass. All right. So now we'll try 10, which is also a multiple of 5, right? And that's going to fail. And you see that we got 10. And we're seeing that we pretty much ran into the same thing that we did with 3. And so we're going to do the same thing here as well. So we're going to say remainder 5, 0. And that should make them all pass. All right, we're going to refactor again and do a very similar refactoring. So, take that. And so now we can buzz or fizz or just 2s. And now we pass again. All right, so now we've got this idea that if it's visible by 3 and 5, then we want to do fizz buzz. So first number that's divisible by 3 and 5 is 15. So we'll say 15 should give us fizz buzz. And we run it, and we got buzz. So that's not appropriate. So again, I'm going to go with the simplest thing here. If n is 15, we're going to go fizz buzz. Else, we're going to do that stuff. And that passes again. So we'll say we'll go 30. That should work for another one of these. That should give us fizz buzz, except it gave us buzz again. So that's not right. So again, we can see that this is following a similar pattern. The only difference now is we can either say that it has a remainder 3, 0 and remainder 5, 0. We can just do it based on 15, which is that common factor there. So we can say n dot remainder 15, 0. That, and then we pass again. And I'm going to refactor that there again. Now we fizz buzz, or we fizz, or we two-string on the end, and we pass on everything. So now we've got these other rules up here that say that if it has a 3 in it, so say 13, then it should also be fizz. So we're going to go ahead and create another one of these here. So when we give it 13, it should be fizz. And that fails though. We got 13 instead of fizz. So we could go ahead and do a little if 13 there. What might be better though is we know we want fizz here, so we can say if remainder 0 or n equals 13. And that passes. All right, there we go, that works. Except 13 is not the only one of those that's going to do that. 23 has a 3 in it, so let's try that out. And that fails, we got 23. So we're going to realize that we can't just keep pouring all those, so let's actually do what it says. It says if it contains a 3, then it should be there. So we're going to go ahead and say n dot toString. We're just going to check to see if it has a 3 in there. And that passes. So now we're good there. Except I don't like that, so we're going to refactor again real quick. We're going to make predicate form of our fizz here. And we're going to just copy what's in there and put it there. And say that. So that works for us. So now let's try, we've also got this rule here that says if it's got a 5 in it, it should be buzz. So we'll go ahead and say 52, I think, is the first one that doesn't fall into other rules. And that should give us a buzz. And that breaks and gives us 52. So we're going to go ahead and fix our buzz function in much the same way. Or and equals 52. And we pass. Drive out a little bit better functionality here. And I think 57 should be buzz, right? 59 for sure. 59 should be buzz. And we get 59 though. So we're going to do something similar to what we did with our 3. We're going to just check to see if there's a 5 in there. And that works. So again, we'll refactor this down here. And grab this chunk here. And say that. And that should work for us. All right. So now we've got this other thing here that says if there's a 3 or a 5 in there, or if it's divisible by 3 and there's a 5, or if it's divisible by 5 and there's a 3, then it's FizzBuzz. So there's a few different cases that can drive that out. So we'll say 35. That's got a 3 and a 5 in it. So if we say 35, we should get FizzBuzz. And if we do that, we got buzz, not FizzBuzz. So again, we'll switch this here, and we'll say 4 equals 35. We'll pass. We'll drag this out a little bit further here. And another one we've got that should fit that rule is 45. 45 follows one of our other ones. We've got, what was that? 53. 53. Actually, I'll go with 51 because that handles the divisible by 3 and has a 5. So 51, and that fails. We get buzz, which is not cool. And so now this is going to get a little bit complicated here. But then we realize that actually what we're saying is that if it's fizz or buzz, then it should be FizzBuzz. Oh, and. Yep, good point. If it's fizz and buzz, then we get FizzBuzz. And so those all pass. And just for thoroughness, we'll clean that up a bit. Since we did it on the other ones, it's not quite as messy, so I don't want to find this one as offensive. But we'll put that in there. And that. And now we've got this taken out, and we can undo our integration test here and run that, and we still all pass. Nice. So now we've got a nice little description on our spec, and we have FizzBuzzing.
Nice.
And questions?
If I can just interrupt real quick, because Jan sent me a note. He said that if somebody has a dark blue or black Honda Civic, their lights are on, license plate 739. Okay, thank you. Thanks, Jan.
Does anyone other than Nick have any questions?
So I have a question.
That was great.
Would you then go and delete all those other tests and just have your one spec?
No.
You would keep them in there just for completeness?
Just like in Rails project, you have your integration tests and your unit tests. This is just a very simplified thing, so I put them all in one area. And this is loosely an integration test, and then I'm using it in a more higher level context that you can imagine that you can then theoretically take that mapped out array and print it out, which is, I think FizzBuzz actually says you're supposed to print out the results 1 to 100.
I got a question.
Oh.
Okay. Given that you define your subject and you have this described hash convert, so you're doing everything correctly, is there some way you can avoid typing fizzbuzz.convert over and over?
Yes.
Yeah.
Is there standard architecture?
Yes. He could have refactored his RSpec to make it feel a little less duplicated. Right, because he only needs to define that he's calling FizzBuzz, convert once with a number, and then within each context, you can define the value of that number, right, and verify that.
But so there isn't some RSpec standard that would automatically call the method convert, given that you did describe convert and your subject is FizzBuzz?
No. No. Because the thing that you're describing in convert is just that. That could say anything. Do that.
I still see I still see a little bit of duplication in the FizzBuzz class. If you refactor that more.
I refactor this more. I got some.
It's longer than my FizzBuzz solution.
Mine's more expressive and reads.
Refactoring doesn't mean shorter.
On an expressive.
Mine is just as expressive.
I wouldn't mind playing some golf with this. Look, I put it on one eye.
So I have a question. I see in the non-predicate forms of the FizzBuzz functions and up in the main convert function, you're using short circuiting. Could you express that by doing like fizz if fizz using a predicate version? So it reads
Yes,
a
yes.
bit more.
You could throw a lot more ifs, or you could use a case statement, or all of that. I decided when I was doing this that I didn't want to use ifs. So I just used logical operators.
Okay.
But yes, you could say if the FizzBuzz question mark in
All right.
FizzBuzz and have an if else chain there. That would work just as well.
I think he was just saying, just like in your fizz method there, just switch the two things around.
Oh, yeah.
It's a little bit more
If
apparent
in
that
between.
it's what's going on. 'Cause
Yeah, you can do
Right.
if fizz,
Yeah.
and that'll work just fine.
Which one would be more preferred in like the Ruby community?
There isn't one.
Okay. Well,
I would prefer the if because
A lot of people prefer the if at the end.
People think using the and operator to cause a different return can sometimes hide what that value is when you're quickly scanning.
It's because most languages will turn that into a boolean.
That's right. And in this case, it's not technically.
Yeah.
Yeah,
actually-
and and or, the words and in Ruby are flow control operators. And so they act differently than ampersand, and pipe. And so because they're flow control operators, I don't have a problem with using them for flow control, which is basically what I'm doing here.
DHH still hates you.
Yep.
I don't, I'm sure DHH hates me for a lot more reasons than that. But, yes.
If you use a line where it says is do some calculation if the flow control, because the if is in the line, it doesn't evaluate the first thing.
Yep. You have to parenthesize it properly.
Yeah.
Do the right thing. Yes. That has to do with the preference order of those operations.
Okay.
Yeah.
I just want to make sure I understand this. In your non-predicate methods, so is that just implicitly returning the fizz? Like it's evaluating the true?
Yeah, so basically what's happening, if you look at the fizz one, so that's saying evaluate fizz question mark in, and that's going to be true or false.
Right.
If it's true, then the and will let it
Implicit.
continue on,
Okay.
and I'm just having a value fizz, which will then be the return value, because the last thing you do in Ruby is always the return value. If fizz question mark in is false, then there's no, Ruby won't try anything past the and because it wouldn't make any sense. It's already failed. So false is the return value. So then on something like the number 2, it's going to flow through here, false or false or false or 2.2s. If you went with the if style that they were just talking about, where if I had done it like this, then it would actually, if I had done them all like that, it would actually be nil or nil or nil or 2.2s. And so it's slightly different in how it would actually play out there.
You sure about that?
I think so.
I thought an if always returned false.
No.
No.
Really?
No, it'll, if it doesn't, if the thing evaluates to false and you don't have an else, then the if doesn't run and you get nil as the return from the method because it's the only line in the method.
It's
Even
nice
on
if
the
you
final.
convert it to a string and nil will give you empty.
An empty string, yes. You can use some of the tricks. You can use some of the tricks around how nil is represented within Ruby, but you're still getting a nil rather than an explicit false. Right, and so by flipping it the other way and putting the and in, Alex is ensuring an explicit false rather than an implicit one through nil.
Anything else?